Sri Akal, Johar. Friends, today we will discuss Hofmann's rearrangement or Hofmann's hypobromide rearrangement. Before we start Hofmann's rearrangement, first of all, let us see here. We will discuss 4 rearrangements in continuation, and all these 4 rearrangements involve electron deficient nitrogen called NiT. Which are these 4 rearrangements? High School Living Certificate. It is High School, L stands for living, C stands for certificate. Okay. Here this H is Hofmann rearrangement. Hofmann rearrangement. S stands for schematic rearrangement. L stands for Lujan rearrangement. C stands for Curtius rearrangement. And these 4 rearrangements involve electron deficient nitrogen, and that electron deficient nitrogen is called NiT. So here we will discuss one by one, and out of these 4, first is Hofmann rearrangement. Conversion of amide into amine with 1 carbon atom less is known as Hofmann rearrangement. And in this rearrangement, reagent is bromine and caustic potash. So you can write here, when amide is heated with bromine and caustic potash, we will get primary amine. Here you can get primary amine, aliphatic primary amine or aromatic primary amine. Means you can take amide, either aliphatic amide or aromatic amide. Okay. Now we will see its mechanism. It is amide. Amide. Bromine reacts with this hydrogen giving rise to N-bromoamide. Now this hydrogen will be acidic because this carbonyl group is electron withdrawing group, and this bromine is also electron withdrawing group. It is electronegative element. So delta plus charge, sufficient delta plus charge will be here on this nitrogen, and due to this electron of hydrogen will be attracted towards nitrogen, and so this hydrogen is released as proton. Means this hydrogen is acidic. Okay. So this hydrogen are negative charge. Now, since bromine is electronegative element and easily it will be eliminated as bromine ion in this fashion, giving rise to this. Friends, underline it that it is nitrene. This nitrogen has 6 electrons, 2, 2 and 2. There are 6 electrons on this nitrogen, and so like carbon, it is nitrene. It is electron deficient nitrogen called nitrene. Now it will come here and this alkyl group will rearrange, will come here with this bond leading to O double bond C double bond N single bond R. Okay, and when it is hydrolyzed, you will get water will attack here, you will get RNH2 plus CO2. It is primary amine. This is all about mechanism. Mechanism of Hofmann's rearrangement. Okay. Now we will discuss its specific features, some characteristics of this rearrangement, that is called specific features. Specific features. First is reaction is intramolecular. Reaction is intramolecular. How can you say? Suppose you are taking CONH2. It is amide and it is metadeutrobenzamide. And suppose this nitrogen is N14 and it is benzamide, also benzamide, but there is no deuterium here, but this nitrogen is N15 isotope. When this mixture is subjected to Hofmann's rearrangement, means when this mixture is heated with bromine and caustic potash, you will get this mixture NH2, this nitrogen is N14, it is metadeutroaniline. Friends, nitrogen is here N14, deuterium is here, This deuterium will not come here where nitrogen is as N15. It is important to underline, okay? Plus NH2, it is aniline where nitrogen is N15. Friends, this nitrogen is N14, this is N14, deuterium is here, this deuterium cannot come here. It is N15, it is N15. And that's why we have written reaction is intramolecular. Okay. Second characteristics of this rearrangement, second property of this rearrangement is optically active amide shows retention in its configuration. Suppose it is C amide group is here, amide group is here, and it is hydrogen. It is methyl, it is hydrogen, it is amide, means this carbon is optically active. This carbon is asymmetric. This carbon is chiral. And it is S. And this amide is subjected to Hofmann's rearrangement. You will get NH2 will be here, hydrogen will be here. Means this configuration is also S. Means this S amide will produce S amine. That's why we had said that optically active amide shows retention in its configuration of the product. Okay. Now third one is driving force of this rearrangement is nitrogen. In the mechanism it is very much clear that driving force of this rearrangement is nitrogen. Okay. This is the third property. Now fourth one, N substituted amide, friends, RC double bond O, N R H. If there will be no alkyl, but instead of this R there will be H, then it will be simple amide. But alkyl is here, it is called substituted amide. This such type of amide cannot give Hofmann's rearrangement because this hydrogen is no longer acidic. Because alkyl group is here, this alkyl group will pump the electron pair and the positive charge on nitrogen due to this carbonyl group is reduced. Positive charge on nitrogen due to this carbonyl group will be reduced by electron pumping nature of alkyl group, and that's why this hydrogen is no longer acidic, and that's why reaction cannot take place here. Okay, these all are four specific features of the rearrangement. Now let us see application. application. First, you can prepare any amide if you take aliphatic amide, you will get aliphatic amine. If you are taking aromatic amide, you will obtain aromatic amine. If you take, suppose it is heterocyclic amide, you will get heterocyclic amine. Any type of amine you can prepare with the help of this rearrangement. And the beauty of the rearrangement is the product contains one carbon atom less. The product contains one carbon atom less. Second application is synthesis of hydrazine. Okay. NH2, NH2. It is urea. When it is treated with bromine and caustic potash, you will get hydrazine. This CO group is eliminated, means one carbon atom less here. Now, third one is synthesis of anthranic acid. Synthesis of anthranic acid. Suppose it is thiamine. Okay, it is thiamine. When it is treated with dilute NaOH, it will be hydrolyzed. It will be hydrolyzed. C double bond O, ONA, and C double bond O, NH2. This. When Hofmann's rearrangement is allowed, means it is heated with sodium hydroxide and bromine, then you will get C double bond O, ONA, and here NH2. Means Hofmann rearrangement will take place at this portion. Now, it is hydrolyzed with dilute HCl, then you will get this. It is anthranic acid. Anthranic acid. Now, friends, it is third application. Okay. Conversion of alcohol into its lower homolar. Suppose it is RCH2 OH. it is alcohol. Okay? When it is oxidized, you will get this alcohol aldehyde. When it is further oxidized, you will get this carboxylic acid. When it is heated with ammonia, you will get this amide. When Hofmann rearrangement is taken place, you will get this amine. One carbon atom is less here. When it is treated with nitrous acid, you will get this alcohol. This alcohol contains one carbon atom less than this. In the similar fashion, you can convert aldehyde into its lower homologue. In the similar fashion, you can convert carboxylic acid into its lower homologue. Then friends, all these are about, it was a complete lecture of Hofmann rearrangement. Okay? Hope you will like this lecture. So, must share and subscribe. Who is not the subscriber of my YouTube channel, Chemistry King. Thank you very much.